Today I would like to talk about the subject that may interest you. I want to tell about our smartphone performance and how the hooks that create often a false view of reality around us. The first thing is today's processors theoretical overclocking. As most of you, I have a multi-core multitask unit. In the past, we as clients were looking mostly at the CPU's clock, and this was the main parameter to approximate the CPU's performance. Some may say that it was not enough, but in reality, there were few processors that with lower clock overcame the units with better one. Especially these situations were uncommon when we compared the same price league hardware. I remember having Celeron 633 MHz when Pentium 2 was the biggest thing and nobody believed me that it had this clock. Here we have to look at another parameter. I mean cache L1 and L2. L stands for level, memory. We should understand this by simply imagining it as a private CPU's memory that CPU can use to perform longer instructions, longer lasting instructions without re-exporting it to main memory RAM. The third parameter that could be interesting but was unified was the magistrate, the max busline travel volume per time unit. We had these processors and we looked how many gates it could use per second, how much data he could cache without using outside memory, and how much that data it could receive and send if he was using outside memory. The first improvement after that was making pretty standard bit improvement. It was constant from the beginning, and it means that our unit can take more data at once to operate with. It is just like the cluster partition size. We simply cut and paste and operate on longer strings, at once comparing 64-bit to 32. We should have the special dedicated software that will send these kinds of order though. Without software we could not use our 64-bit improvement. We should also understand that we could use 64-bit units for 32-bit instructions, but we could not use 64-bit instructions on 32-bit unit, because the both parts together didn't anyhow match for one total 64-bit ones. For example, one had XX and other had XXXX, and we have all the 00XX, 01XX, 10XX, 11XX instructions more to master. So in one we have 4 different XX parts, but we have 4 times 4, not 4 plus 4, more possibilities than when we use twice as long chain. When we take a 64-bit versus 32, it was 32 times 32 more instructions, not 32 plus 32. It doesn't equal 64-bit. Then we had this problem that futurizing the CPU's clock was out of the option. We should know that then we could sometimes raise the speed of our processor by raising the voltage it received and used for counting. The higher voltage current is flowing faster. It have higher potential. There were people that could raise the speed of our clocks to 5 GHz and more. 5 GHz was the last real option, but it needed such advanced cooling equipment that it was too complicated for everyday usage by anyone, and also too expensive comparing to the price rivalization. I want to tell that there were many processors overclocked from the beginning, especially when optimally it made X.700, and after rising it could have X plus 1 at the beginning. The price was its lifespan. There are many units we could underclock and make them operational for a lifespan of other discrete elements on board. The risk was that after overclocking, and no one really could oversee how will 2 years of overclocking suffer the processor, and this time was crucial because of the warranty. The normal thing, though, was rather overclocking different units and the benchmark rivalizations between people from over the world. Today it is not the problem, because even if earlier producers had offered BIOSes with overclocking options on their websites, later it was pretty much banned and locked in the driver software. There were no options left to continue Moore's law of making 2 times performance every 2 years, then making units that were in reality the puzzle of few standard ones on one socket we always had on our motherboards. So then it started. Every next generation had firstly more cores, but after some time these overall large cores were divided in the way that they could perform few tasks, emulating more cores for less complicated tasks. So today I have, for example, in my telephone 8-core processor, and every core can be divided to do 8 different tasks. In total, this means that it should be 64 times better than single one. Reality is much darker though. Different cores have different clock speeds. 2. The clock speeds have to be synchronized to properly work together, not mentioning that even today's RAM have its own clock. 3. For optimal effect, we have to send the data to the CPU that will let him divide our tasks between all units. What if something's already working? 4. We could not have time to divide and glue everything together. 5. We have limits in our bus lines that today don't allow us to send proper volume of data simultaneously and send them to different cores separately. 6. We usually need to have software that will translate its work for every fucking option people had created. It is rarely prepared to use all cores and tasks, not mentioning their speeds, caches and bus volumes, not mentioning that often cache is shared between different cores. But all that looks even funnier when we will realize that our phone uses 3.7 volts, 1 ampere maybe, and it illuminates, plays songs on built-in speaker, connects via GSM, Wi-Fi, Bluetooth, operate the touch screen in 24-bit color range, run many apps at once, and give enough power to all these cores. It is miracle, you know. There is no miracle that will provide you the catalog speeds of these cores. You see, the reason is that the cores can have sent and receive data 10 or 100 times higher speed than their clocks are. What I mean is that 2.0 gigahertz units are in real 200 megahertz units that can start the counting 100 times faster. It would not count 100 times faster, but the difference will be that it would start counting, at example, 1.9 gigahertz. It will count using 200 million operations per second, and it will give the answer in hertz 200.050, not in 200 first. When you don't believe me, imagine that today's graphic cards need 800, 1000 watts to operate, and phones have maybe 5, max 10 watts, max for all performance. How we could not see this for such a long time? You see, the producers see these things, they know about them, but it is rather some kind of, I don't know, quiet agreement or something, because, you know, it is hard to think about that you are sitting at first you're sitting on 2 gigahertz units, and you are when you're taking phone, you are going back to Pentium 2 in real. So they write it like it, but look at that the applications on the Play Store or iOS applications for smartphones are not quite the quality you can meet in PC games. Also, it is somehow underrated when we talk this way, because today there's VRAM, and also phones have faster RAM nodes, and it is performing better. Also, when there are many cores and every one of them will be taken. So we have 64 200 megahertz processors at once. So it will count simply faster. I tell you all this because we should know that there is a problem to erase it. So look at the hands of producers and encourage them to somehow make it happen, that we will every time use, for example, minimal 18% of our equipment performances. Because it is rather sad when you have 64 theoretical processors, and every application you use takes one, maybe two cores, and when the second one is taken, the other one won't use it. Everything is waiting for another. And there are also other problems, because how to benchmark all this, how to tell which one phone is better. I want to congratulate Motorola, because I have a Motorola phone, because they we simply maybe achieved the third three times performance in the benchmark 3D Mark than it was before. After actualization of the software, it performs three times better in some applications. So this is all for today. See you later.